Okay, so in this example, we're asked to show that 2k plus 4 times x squared plus 3k plus 2 times x plus k minus 2 equals 0 always has real roots. We want to show that this is true, okay? So when something always has real roots, we know that b squared minus 4ac is going to be greater than or equal to 0. Okay, so now we need to think about how we're going to solve this, okay? So these 2k's, 3k things in front of our x's, they're just the coefficients. So this is just a, different colors, b and c. So then this just becomes b squared minus 4ac greater than or equal to 0 just becomes 3k plus 2 all squared minus 4 times 2k plus 4 times k minus 2. This is all greater than or equal to 0. Okay, so I'm going to switch back to one color for the moment, but then you can just see how where the different coefficients come from. So this bracket, well, 3 squared is 9k squared. Put these two together and double them, plus 12k, square the last term, plus 4 minus 4, well, 2k squared, and that's going to be minus 4k, then this one's going to be plus 4k, and then I think, yeah, that's that. Oh yeah, then 4 times 2 is negative 8, and this is still greater than or equal to 0. So these will cancel. Then what are we left with? 9k squared plus 12k plus 4 minus 8k squared minus, well, 4 times 8 is 1632. So we were minus, oh no, 4 times 16, 16 plus 16 is 32. So minus 32. Okay, but minus that becomes plus. Okay, so this becomes 9k squared plus 12k plus 36 is greater than or equal to 0. Then again. Okay, so now this just looks like a normal quadratic. Okay, so now we just need to factorize this. Well, what's going to multiply to make 36 and add up to make 12? Well, 6 and 6. So this becomes k plus 6, and then k plus 6 is greater than or equal to 0. Well, because it's double bracket, we write it like this: k plus 6 squared, because that's exactly the same thing as writing it this way. It's always greater than or equal to 0. Okay, so we're kind of finished now. Now we need to answer the question and show that this expression always has real roots. So how do we know that this is always going to have real roots? Well, it's actually because of this squared term here. Because of this squared term, no matter what the value of k is, this expression is always going to be greater than or equal to 0, okay? No matter if you put a negative number in there, positive number, no matter what happens, is always going to be greater than or equal to 0. And I've got a graph to help try and explain this a bit more. Here's our expression of y equals k plus 6 squared, right? And I've drawn the parabola of y equals x squared plus 6. Okay, so I'm going to play this now. So what I'm showing you here is no matter what value of k you have, it's always going to be a positive number or 0. So once I'll slow it down even more. So here we've got a negative number, we've got negative 8, but still it's not less than 0, okay? And as you go back, you're going to go to negative 6, and that's when it will hit 0. And then as soon as it's above that, it's just going to keep increasing, okay? No matter what number you put into this value for k, it's always going to be positive. And that's what the expression means when we say show that it is always positive.